Hello students, today we will discuss the fetal circulation. So we consider it as the last lecture of CBS embryology for your syllabus. So we will discuss the fetal circulation in detail today. So developing fetus receives the nutrition from placenta, you know it. Fetus is dependent on mother for what? That is intake of nutrients and oxygen and excretion of carbon dioxide and waste product. What are the special structures in fetal circulation? Number one is the placenta, which is the site of exchange of substances between mother and fetus. So then is umbilical vein, then which carries the nutrients and oxygen to the fetus. Then is umbilical arteries carrying carbon dioxide and waste products away from the fetus. Next important structure which is concerned in the fetal circulation is foramen vein. So this helps the blood to bypass the lung. Transmits the most of the blood from right atrium to left atrium. Then next important structure is ductus venosus, which transmits the oxygenated blood from umbilical vein and left branch of portal vein to inferior vena cava. So what is the important you can see thing which happen over here is they just bypass the liver, ductus venosus. Now ductus arteriosus, it helps blood to bypass the fetal lungs. So main aim of foramen vein is that it is just connecting the blood from right atrium to left atrium, just transmitting the blood, mixing of the blood is happening. Ductus venosus is bypassing the liver. Ductus arteriosus is bypassing the fetal lung. So it transmits the blood from left pulmonary artery to the aorta. So this ductus arteriosus. Now fetal circulation is different from adult circulation. So three basic reasons for the difference is blood in the fetus is oxygenated by placenta and not by the lungs. So in the lung the purification is happening in case of adult circulation. Then during fetal life the lungs are collapsed. Hence the resistance to blood flow through the lung is much higher. As a result, only minimal amount of blood passes through the lungs to supply oxygen and nutrients to the lung. So this is the difference, because they are not inflated, or they are, in other words, you can see the lungs, they are collapsed in fetus, so resistance is high. Then third is portal circulation is of little significance during fetal life. Now see the diagram. Now I told you the main component, that is umbilical arteries, umbilical veins, placenta, then ductus venosus, then foramen vein, then ductus arteriosus. So I told you these important components of the fetal circulation. Now how the fetal circulation it happens? The oxygenated blood from placenta, you can see this is the placenta. The oxygenated from the blood from the placenta is taken up or reaching to the fetus through left umbilical vein, then traverse through the umbilical cord, then enters the abdomen through umbilicus. Next is passes to the liver. You can see in the diagram the blood is entering into the liver. So from placenta, umbilical vein, umbilical cord. So umbilical cord is running through the umbilicus, entering into the abdomen and reaching the liver through falciform ligament. In the liver, the left umbilical vein joins the left branch of portal vein. Now you can see here, this is the portal vein. The left umbilical vein is joining the left branch of portal vein. Most of the blood from left umbilical vein bypass the sinusoid of liver by passing through ductus venosus. So the blood is not entering into the liver. So it is just bypassing the liver through the channel, that is ductus venosus. So a channel that connects the left branch of portal vein, you can see here, left branch of the portal vein to the IVC. So this is the ductus venosus. So blood it remains within a conduit. So it is not entering into the liver. It is just bypassing the liver. Only small amount of blood of left umbilical vein enters the liver sinusoid and mixes with the blood from portal circulation. Now IVC open where? That is into the right atrium. You can see in the diagram, this IVC is going to open into right atrium. In the IVC, richly oxygenated blood from placenta mixes with the deoxygenated blood from the lower limb. So that is mixed up with that. Then blood enters the right atrium. It is guarded by the valves of IVC towards the foramen ovale. Now you can see the movement of the blood is happening from right atrium to the left atrium through foramen ovale. Most of the blood from IVC passes through foramen ovale to left atrium. Only a small amount of blood from IVC is prevented from doing so by lower edge of septum secundum, the crista dividens. So here is the crista dividens is there, you can see. So small amount of blood is entering here and majority of the blood is entering into the left atrium. Thus it remains in the right atrium and mixes with the deoxygenated blood from superior vena cava and it passes to the right ventricle. From right ventricle, the blood goes to where? That is into the pulmonary trunk. So from the right ventricle, it is entering into pulmonary trunk. From pulmonary trunk to right and left pulmonary arteries. There is high resistance in pulmonary tissue during fetal life, I told you. Then only a small amount of blood enters the pulmonary circulation and most of it passes into the aorta through ductus arteriosus. Now you can see the communication of ductus arteriosus over here. Because of the resistance, because left and right pulmonary artery has to go to the lung, but they don't have an open door welcome over there. So the blood is entering through a channel into the aorta. So this blood is entering here through ductus arteriosus. So this is the channel connecting the left pulmonary artery to arch of aorta. Left atrium receives the mainly richly oxygenated blood from the right atrium through foramen ovale. Only a small amount of deoxygenated blood enters the left atrium through the pulmonary veins. Now, what are the different peculiar features of fetal circulation? Number 1, blood shunts 3 times in fetus at the following places, that is ductus arteriosus, foramen ovale and ductus venosus, to bypass lungs and liver. Second is regulation of the oxygenated blood in fetal circulation. Sphincter at the junction of left umbilical vein and ductus venosus regulates the flow of oxygenated blood to the fetus. That is important. Then is mixing of oxygenated and venous blood take place at the following sites. Where? That is in the liver, both atria, distal part of the arch of aorta through ductus arteriosus, then terminal part of IVC. Then transseptal blood circulation. Through foramen ovale, blood enters from right atrium into left atrium. Then length of the upper limb is more in fetus, so upper limb bud receives more blood than lower limb. So what are the circulatory changes happening at birth? After birth, placenta, the fetal organ of respiration, is separated from the newborn and lungs start oxygenating the blood. So respiration is established. Now the oxygenated blood comes to the heart from lung. So following changes take place in fetal circulation. First, in the umbilical vein, no longer carries any blood from placenta. So umbilical vein obliterates and it forms the fibrous ligament called ligamentum teres. Then second change in ductus venosus is it obliterates. It forms a fibrous ligament, that is ligamentum venosum. Then as the lungs are inflated and the pulmonary circulation is established, the pulmonary veins bring more blood to the left atrium. And what is the next change? As the presence of blood is more in left atrium than in the left, it is more in the you can say left atrium than in the right atrium. So there is one correction over here. So this is right atrium. So right atrium, the septum primum is pushed to the right and the foramen ovale is closed. So please read this statement as the right atrium. So blood is more in left atrium than that in the right atrium. At first, the closure of foramen ovale is physiological. Later on, septum primum fuses with septum secundum leading to anatomical closure of foramen ovale. So closed foramen ovale forms the fossa ovalis, you know it. The next change in ductus arteriosus is it obliterates and the remnant is known as ligamentum arteriosus. Then four umbilical arteries, right and left, they obliterate. However, three proximal part remains open. The proximal part of the umbilical arteries form the superior vesical arteries, and distal part form the fibrous ligament which is known as medial umbilical ligaments. So these are the changes which are happening during the fetal circulation, or once the baby is born. So what are the different changes they are happening and how they remain as remnant in the adult body. So this is the fate of the different structures which are involved in fetal circulation. So following changes take place in the fetal circulation. Muscle contraction in the umbilical arteries occlude their lumen and prevent blood loss. Umbilical vein contract a few minutes after the umbilical arteries. This mechanism allows the newborn to receive more blood from placenta. Then occlusion of ductus arteriosus diverts the right ventricular blood to the lungs. Then closure of foramen ovale due to increased pressure in left atrium. So this is all about this. Next change is happening that whatever be the embryonic communication is there and it closes because of vasoconstriction, we call it as physiological, soon after birth. But later on what happens, the proliferation of the intimate happens, which is given the name anatomical closure. Now the complete obliteration of the lumen of the umbilical arteries and ductus arteriosus take place in 2 to 3 months after birth. Anatomical closure of the foramen ovale take place in about 1 year after birth. So again, so what I have told you, so that is in one slide. So umbilical vein, they persist as ligamentum teres after birth, ductus venosus as ligamentum venosum, foramen ovale as fossa ovalis, ductus arteriosus as ligamentum arteriosus, right and left umbilical arteries that persist as superior vesical artery and right and left median umbilical ligaments. So this is all about the fetal circulation, and with this we have finished with the development of cardiovascular system. So thank you very much. So kindly, again I request you to kindly subscribe my channel, like it and share it. Thank you very much.